In the last video, we talked about how to get the volumes of regions that are rotated about the x-axis. In this video, we'll talk about what has to happen when you rotate around the y-axis. So here's the y-axis, here's the x-axis. And let's suppose we've got some region here. We spin it around the y-axis. How can we find out the volume of that? Now, slicing vertically as we're used to doing, it can be done, but it results in a very complicated integral. This is called the cylindrical shell method. Instead, that's not the best way to do it usually. The best way to do it is just to swap the roles of x and y. So instead of slicing vertically, we're going to slice horizontally. We take our region, we slice it horizontally, and then we say, what happens when you rotate this interval around the y-axis? Well, you get a washer. You get this region spun all the way around. You get a washer whose inner radius is that distance and whose outer radius, that's the outer radius. And so what's the area as you rotate around the y-axis? It's a function of y, and it's the outer radius squared minus the inner radius squared, all times pi. And the volume is the integral of a of y dy. It's exactly the same as what we did when rotating around the x-axis, only every time you had something involving x, now we have something involving y. You just swap the roles of x and y. So for example, let's look at this region. This is the region around the curve y equals square root of x, and the line y equals 2, and the line x equals 1. So this is the region, and we're going to spin it around the y-axis. So we get this other curve here. So it's this spun all the way around. So in this case, the outer radius is we have to figure out what value of x corresponds to a given value of y. So instead of writing this curve as y is a function of x, we write x as the inverse function. We say x is y squared. So the outer radius is y squared. The inner radius is 1. So our volume is the integral as y goes from, well, let's see, when x is 1, y is 1. So y goes from 1 to 2 of pi times y squared squared minus 1 squared. So that is the integral from 1 to 2 of pi times y to the 4th minus 1 dy. And that is pi times y to the 5th over 5 minus y evaluated at 2 and at 1. So that's pi times 31/5 minus 1, which is 26 pi over 5. Okay, there's the volume. Now, if you really wanted to slice things vertically instead of horizontally, there is a method for doing that. It's called cylindrical shells, and we'll touch on that in the next video.